The Alternate Reality Kit is an environment for creating interactive animated systems. It's intended to be a world of parts and pieces that the user can modify to assemble their own microworlds. The system is being implemented in the Smalltalk 80 language and runs on a computer with bitmap display and mouse. In the Alternate Reality Kit, the normal Smalltalk mouse pointer shown here is replaced by a hand. The hand can be used to pick up and carry objects, to throw them, and even carry them between worlds. These two objects shown here are special objects called interactors. They represent some interaction law of the environment, such as motion or the law of gravity. For example, if I start an object moving, remove the law of motion from the world, I can carry it over to the other one and introduce the law of motion here. The user communicates to objects by pressing buttons. For example, by turning on the law of gravity here, I can start a gravitational attraction going between this moon and the planet. Users can playfully throw any object around so they can try to discover different kinds of orbits that are available. The buttons can be picked up and carried over to other objects. For example, by turning off the law of motion, I stop any motion of the planet and the moon or any objects in the environment. By trying to drop a button onto an object that doesn't understand the message, the button is made to simply fall through. That prevents a certain class of errors. One of the more useful messages is the Xerox button, which is used for making copies. This way I can have a law of motion simultaneously active in this world and this world at the same time. Another useful button is the vaporize button. Let's look at getting inside the law of gravity here so we can modify it. In order to create new buttons, the user uses the message menu button. That button will give you a menu of all the possible buttons understood by the law of gravity. Selecting from the gravity category, subcategory accessing, Set G gives us a button that will set the universal constant of gravity operating within the law of gravity. This is an unusual button because it has a parameter to its message. That is a little plug to be dropped on a numerical value for G. Let's go back into here in the warehouse. We can create a number scale and find a slider to attach on top of the number scale, and that's a handy way to create numerical values. And now this is attached and ready to be pressed. We've changed the value of G inside the gravity law. Now, because buttons are themselves physical objects, they respond to other buttons. I happen to have already created the toggle permasend button here. That puts the button into permasend mode, which means that the numerical value is continuously relayed into the button and down through into the law of gravity. The use of animation indicates that things are active. The plug is continuously relaying the value here, the button continuously relaying the value into the law of gravity. For example, if I drop that out of no man's land, the button stops relaying things because it's not attached to anything. We can now play with our modified law of gravity and try even negative values to see what would happen if Newton's universal constant of gravity were negative and positive, and generally interact with a way that's completely impossible in the physical world, with which you can discover the role of this constant of gravity, discover what it does in the universe. What would happen if we specified not a numerical value, but something silly like a button as the law of gravity's universal constant? So instead of a number here, we're setting capital G to a button, not a number. If I try to activate the law of gravity now, an error object is created. So even errors are represented within ARC as physical objects. Essentially, the button has text on it describing the problem, which was that the button didn't understand how to multiply itself by 30. I'm vaporizing this object with a special combination of mouse button presses, the first and third button together. It's such a handy thing to do that I have a special shortcut here. Let's go look at the warehouse and find some other things that are in there. Not only are there useful ARC objects, but everything in the underlying Smalltalk environment, which is a purely object-oriented environment, is available. For example, this clock view can be made to appear, and even things like the system compiler. Once again, these are not objects that I have made, they're objects from the underlying environment, and the alternate reality kit knows how to create them in a physical representation automatically. If I press the special message menu button on the compiler, I will get all the messages available for a compiler. Automatically will be shown up here as a button. This is a very complicated button with lots of parameters and a little white rectangle for displaying the result of the message. This message essentially is for evaluating a string object. So let's go to the warehouse and create a Smalltalk string object. For example, let's press 3 plus 4. There's a Smalltalk string for 3 plus 4. We specify that as the parameter to the evaluate message. You can see the answer displayed here, 7. The possibility of making arbitrary Smalltalk objects appear as physical entities raises the possibility of using ARC as an user interface kit. In this application, a mail writer object was pulled out of the warehouse and its image graphically edited to look like a mail truck. When the deliver button is pressed, the argument to the deliver message, which is a Smalltalk string object, is delivered as a piece of electronic mail in the Smalltalk electronic mail delivery system. In this application, switching software for a video network was loaded into the alternate reality kit, and little pieces were created, little cameras and little monitors, to represent video sources, including video disc players, video cassette recorders, and even remote cameras such as this one in someone's office in Portland. Cameras can be picked up and carried back to a workshop area where their state can be changed or updated as necessary. Here we are back with the compiler scenario where we were a moment ago. I'm going to clean this up and show you some of what's involved in piecing together a little application. Again, I'm using the special combination of mouse buttons to vaporize things. Let's go into the warehouse and get a very generic ARC object. It's a simple rectangle with simple physical attributes. And do a little bit of graphics with a marker object. Marker is like a primitive little piece of coal that can be dropped on something and will leave a mark. We can send messages to these markers, such as getting it to become slightly larger by giving it a grow message. It's a little bit bigger there. And let's get a copy of that. Tell the copy to change its color. Under ARC marker, change color. And that turns it into white, I believe. Whoops, come back here. Okay. All right. And in fact, let me make a copy of that and create even a larger marker that we could use as an eraser. I'll make it quite sizable. One more here. Let's change its color so it becomes a nice neutral shade of gray. All right. And this can be used sort of like a brush to wipe out the whole surface. Now, because the markers are physical objects, we can introduce an interaction between them. Let's get a spring force. The spring force will not automatically enroll all the objects in the reality into it. That would be a real nuisance to have everything connected to each other by springs. So we have to explicitly enroll the markers. Move him a little farther apart. Enroll the black marker. And now they're interacting with each other as though there's a spring between them, and this is an easy way to create a strip chart recorder.
ARC is a natural for physics teaching applications. In this example, a bubble chamber was simulated. Users have control over the speed of light and other more mundane variables. A bubble chamber is a device that reveals tracks of elementary particles. These particles were simulated by specializing marker objects. An electric charge attribute was added to the markers, and they were given relativistic rules of motion. The modified markers were then shrunk down to a very small size.
This application is an experiment in giving students the ability to violate conservation of energy and conservation momentum in order to give them a way to learn about those laws. Suppose the user wished to create a new kind of interaction, a force of friction that's not currently found in the warehouse, for example. We'll start by asking objects for its velocity, which is displayed here. The resulting vector is accessible with the message menu button, and we can do arithmetic with it. We're going to try to multiply it by a negative number to create a vector that points in the opposite direction to the direction of motion of the object. The resulting vector will be added in as a force acting on this large marker, and we should have a combination of buttons that acts as though there was a frictional force. We can try it out by throwing the object, pressing the button, and as you can see, the size of the vector components shrink. Okay, what we want to do now is combine all these buttons into a brand new button, one that isn't found anywhere in the world. I had to go make it character by character in the warehouse, a friction button with one parameter. The parameter will be the small negative number over here, so that could be a changeable attribute for the friction message. We're going to tell this new button to swallow this combination of buttons over here so that we'll act in a way equivalent to that combination. And here's our resulting friction message, which should act to slow the object down. In this way, though, we can only get friction acting on this one object. What we'd like to do is convert this button into an interactor, that is, promote it to a law of nature. There's a message here that will do that. Again, I'm indicating to the object to save the numerical value over there as a parameter. The button is then converted into an interactor, and we can now have it act on many objects at once, not just this pen, which will be slowed down, but by explicitly adding in our white marker up here and the black marker. We can now do a lab with damped harmonic motion. I'll do the strip chart recorder trick again. And wait till the markers get on the paper, and turn on the spring force, and you can see that the peaks of the oscillation are exponentially damped due to the presence of friction.
The implementation of the alternate reality kit continues to evolve, but the fundamental character of the system will remain unchanged. The physical world metaphor, the way in which everything appears as a material entity, including normally intangible objects like a compiler or the law of gravity. This physical manifestation influences the feel of applications that are developed in ARC and will influence the user's experience with these applications. It's hoped that users will come to have a sense of operating in a kind of self-contained reality, a reality that's enough like the everyday world so they know what's going on, but one that has room for any magic the user may wish to include. Ideally, users will come to forget that what they're watching is merely a video image. Thanks for watching.